I'm going to explain what the problem is, and later on, one more problem I will provide you to solve. That is over there, I will not provide any solution. You have to solve that problem. So let's start. First of all, as we have discussed yesterday, this is somewhat different problem, and the problems which we have seen in the previous lectures, that problems are of principal stress type. This problem is of combined stress, and again we are going to take the shear stress and bending stress as the combined stress which are acting on any component. Now, as far as we have considered this problem, the combined stress, how to tackle that combined stress, that we already seen in AME, as well as we have discussed in detail what the combined stress is and how we are going to deal with the combined stresses. What are the various formulas by means of which we can calculate the principal stresses, as well as how to take the stresses for designing of any component when combined loading is taking place, that is torsional and bending, or uh, we can say basically it is shear and principal stress, or shear, tensile and compressive type of stress, that already we have seen in details. So I'll read this statement once again, and then we'll solve one by one all these problems. Okay, so let's start. A hot rolled sheet, sorry, just a minute. Yeah. A hot rolled steel shaft is subjected to torsional movement that varies from 330 Newton meter clockwise to 110 Newton meter anti-clockwise. Okay, here in the problem, manufacturing process has given as a rolling, and torque which has applied is plus and minus type of nature, that is clockwise and anti-clockwise. We'll say clockwise as a positive and anti-clockwise as a negative. That's why this 330 Newton meter is positive one, and this 110 is negative one. Okay, so when we are going to consider the stress cycle, which already we have seen yesterday. On y-axis, we are going to mention torque in Newton meter. On x-axis, we are going to mention time. And if you want to have the graphical representation of this torque, this is how this torque is varying. And this x-axis is crossing to y-axis at 0. Okay, so below 0, this 110, and above 0, it is 330 Newton meter. This is about the torque. Next statement is that an applied bending moment at a critical section. Critical section, that is nothing but where we are going to, okay, when we are going to design this shaft, at that time we are going to consider this critical section means where that shaft may be weak or weakest, we can say. That's why we are going to say as a critical section. Otherwise, in problem it has been stated that the shaft is of uniform cross section. That's why everywhere where you are going to consider that shaft, that can be taken for the calculation. That area or cross section area can be taken for the calculation. Okay, this type of shaft it is. Which are subjected to torsion stresses. Okay. Okay. And it is subjected to bending moment of 440 Newton meter. Okay. To minus 220 Newton meter. That means this bending moment, which is varying from plus to minus, again the same nature will be there. Now we cannot plot on the same graph, or we cannot say the same curve for the bending moment also. We have to draw separately if you want to draw. Otherwise, we just want to have these figures. No need to draw this graph. Okay. The shaft is of uniform cross section and no keyway is present. Keyway or all other what discontinuities or change in shape or geometry of that shaft. If the changes are there, then we are going to consider the stress will get concentrated over there. Here it has been mentioned that no change is there on cross section or for the cross section of that shaft. So stress concentration factor will be 1 if you are going to consider it. Okay. Then next is that the material has ultimate strength sigma u or SUT is 550 meganewton meter square. Now this meganewton meter square that we are going to convert into Newton meter square, or that can be converted into Newton millimeter square. And yield strength is 110 meganewton meter square. Okay. So yield strength is given and ultimate tensile strength is given. Take the endurance limit as a half of ultimate tensile strength. That is half of this 550 meganewton meter square. Factor of safety as a 2, size factor as a 0.85, and surface finish factor as a 0.62. Okay. All the factors which we have seen, where we are going to convert this SE dash to SE, that is endurance limit, which we have calculated from Moore's experiment, to the endurance limit for the practical application, that Ka, Kb, Kc, Kd, Ke, Kl. Out of that, only we have to consider, because no other factor has been given in this statement. That's why just we have to consider size factor and surface finish factor and stress concentration factor. Here it is mentioned, no Kva is present. That's why that stress concentration factor can be considered. Now all the parameters are given, that is T max, T minimum, then M max bending moment, maximum bending moment, M minimum minimum bending moment, sigma u ultimate tensile stress, then sigma y yield tensile stress, then endurance limit, that is sigma E or SE, that endurance limit, and factor of safety and size factor, surface finish factor. Okay. First of all, we will calculate the mean torque which has applied on this shaft. So just calculate that mean torque by means of this formula, and you tell me what will be the value of this mean torque, which I can mention somewhere here. And this will be the value of mean torque. Okay. Calculate it and tell me what will be the mean stress value. Hello? First of all, calculate T mean and T maximum. Anybody has calculated it? Hello?
110.
110. What is unit for that?
Newton meter.
Newton meter? Newton meter. Okay. Just a minute. I will check it out whether it is 110. Anybody else?
Yes, sir. 110.
110. Everybody has to calculate it. Okay. You should have a calculator and pen and paper with you. 110 Newton meter. How many of you have got that answer?
Yes, sir, 110.
Okay, 110. Rest of others, please mention your answer either in chat box or you can unmute yourself and give answer.
Yes, sir, 110.
110. Okay. Mali, what answer you are getting? Hmm? Hello. Amul Mali. Akashmani. Okay. Okay. Then put calculate 110 if it is, then calculate what? Variable stress value. First of all, you calculate variable torque, TV. That is T max minus T min divided by 2. Min means here minimum. Okay. What value you are getting for average torque?
220.
220. Okay. So let's check these values. It is 110 and 220. It's 220 and first value which you are going to get is 110. Okay, once you calculate this torque, then calculate the stress which will get induced because of the torque, as you know the formula. How we can calculate stress from torque? Is the tau is equal to 16 T divided by pi d cube. Whereas if you want to calculate the mean shear stress, then we have to use the mean torque. And if you want to calculate the average shear stress, then you have to take the average torque. So what will be the value of mean shear stress which will be applied on that shaft? 16 Tm pi d cube. Just calculate this value and average stress, shear stress which will be induced in that shaft. In terms of D, you will get with this value. What value you are getting? Hello, calculate it. It is not that much difficult. You know the formulae and you don't know the parameters which are there in that formula. Tm, just put the value of Tm which you have calculated right now.
Five 60.22 divided by d cube.
560.
Ah.
Right. Okay. Anybody else? 560 divided by d cube. Newton meter square. Am I right?
Yes, sir.
Okay. But who is going to decide that unit Newton meter square? Unit of torque. Anybody else? What answer we are getting? We got the 7 answers and is 560.225 divided by d cube. 560 divided by d cube. Okay, and T average. I'll calculate T average. Okay, sufficient answer we have got for the T mean. What is the value of T average? T average. Put the value of T average and calculate average shear stress. It's 1120.45 divided by d cube. Yes, 1120 divided by d cube and 560 divided by d cube. Okay, so these values we have got for the mean shear stress and average shear stress. Who is going to decide this unit? This unit of torque is Newton meter divided by meter raised to 3. So meter will get cancelled, meter square will be remained here, and Newton will be at the above side. That's why Newton meter square, that is the unit of stress. Okay. Now, when we are going to calculate the endurance limit as far as the shear stress is considered. Now listen carefully here. Okay. This formula or this relationship has not mentioned anywhere in the statement. This we have learned, or just if those are those who are not remembering where we have seen it. Okay, that table was provided actually. So just listen it carefully. Shear stress and principal stress, they have specific relationship with each other that we have seen in Moore's circle. Okay. Now here for the endurance limit also, that the principal endurance limit stress, that is either it is tensile or compressive endurance limit stress or endurance stress, is actually 0.55 times of that endurance shear stress. What I said, जर आपल्याला shear endurance limit कॅल्क्युलेट करायचं असेल आणि आपल्याला जर प्रिन्सिपल endurance limit माहिती असेल तर shear endurance limit हे 0.55 प्रिन्सिपल endurance limit एवढं असतं. ओके. दुसरी गोष्ट, yield strength जर आपल्याला माहिती असेल तर त्याच्या हाफ आपण नॉर्मली yield shear stress घेतो. जर आपल्याला प्रिन्सिपल yield स्ट्रेस माहिती आहे, टेन्साईल yield स्ट्रेस किंवा कॉम्प्रेसिव्ह yield स्ट्रेस, ओके, तर आपण शियर yield स्ट्रेस हा त्याच्या हाफ घेतो. असं आपण नकल जॉईंट, क्वार्टर जॉईंटचे प्रॉब्लेम सोडवताना तो फॉर्म्युला डिस्कस केला होता. ओके. या दोन रिलेशनशिपचा उपयोग करून just what we have to calculate, one is endurance shear stress and yield shear stress. Okay. So here the endurance shear stress is 0.55 of principal shear endurance limit. So principal endurance limit has given in the problem, that is the half of the, here you can see, take endurance limit as a half of ultimate strength, and ultimate strength is given as IU50 meganewton meter square. Half of that, it will become 275 meganewton meter square, and we have to take its 0.55 value. Is 275 into 10 raised to 6, that will be in Newton meter square, and 0.55 of that. That's why this endurance shear stress will be 151.25 into 10 raised to 6 Newton meter square. And yield shear stress is half of the principal yield stress. Okay. So yield shear stress is 0.5 of 410 into 10 raised to 6, that is equal to 205 into 10 raised to 6 Newton meter square. Okay. If you got these two values, then we have to just draw either Soderberg or Goodman diagram. Anyone here you can prefer, because both values are given. So which you will prefer for this? That will see later on. Okay. So here you can have this graph. On this side, y-axis, you will put tau e, and on x-axis, you will put tau y, and you will join this line, and that will become either Goodman's line or Soderberg line. Okay. And based on that, we are going to use Soderberg line. This is Goodman line. And based on that, we are going to choose either Soderberg or Goodman diagram. That will decide later on. Okay. Are you remembering this? Or I'll take the previous one. Yes, this diagram. So this diagram which we are going to refer for torsional shear or torsional stress or shear stress, actually. Basically, it is for the shear stress, because torsion is going to create the shear. So this line is going to become Goodman line. This line is going to become Soderberg line. Okay. And this modified Goodman diagram has shown in this figure. Next, we have to calculate the actual endurance limit, because this endurance limit which we have calculated is the endurance limit for Moore's experiment. Then actual, that is SE is equal to K into KB into KC into KD into KE, KF into K SE dash. Likewise, this SE dash we have calculated, or tau E dash we have calculated. Here we have to calculate actual endurance limit, and that is given by mean shear stress plus average shear stress multiplied by yield shear stress into Kf. This is the stress concentration factor. Then divided by Ke, that is the endurance shear stress, into surface finish factor into size factor. Okay. That is nothing but, again, this formula is directly given for the Goodman relationship. Okay, this is for the Goodman relationship. Otherwise, we can calculate by our convenience way, that how we to convert that SE dash to SE. Likewise, tau E dash to tau E. Are you getting it? I'll repeat it once again. हे जे इक्वेशन लिहिलंय, हे इक्वेशन ऍक्च्युली आपण मॉडिफाईड केलेलं आहे, आणि जे सोडरबर्ग डायग्राम वरनं कॅल्क्युलेट केलंय. म्हणजे इंड्युरन्स लिमिट, ऍक्च्युअल इंड्युरन्स लिमिट बरोबर मीन शियर स्ट्रेस प्लस ऍव्हरेज शियर स्ट्रेस मल्टिप्लाइड बाय यील्ड शियर स्ट्रेस into factor, that factor is stress concentration factor, divided by endurance shear stress multiplied by surface finish factor multiplied by size factor. Okay, actually हे जर तुम्ही सोडवलं तर तुम्हाला गुडमन्स रिलेशनशिप मिळणार आहे. म्हणजे टाऊ एम डिवाइड बाय टाऊ वाय प्लस टाऊ ई डिवाइड बाय व्हॉट. हॅलो. Okay, tau m divided by tau variable divided by tau e is equal to 1 over n, where n is the factor of safety. And if you are going to take into account these all factors, size factor and surface finish factor and stress concentration factor, this formula will become like this. कोणाला समजलेलं नाही, he can ask question at this place only. यासारखा ठीक.
Yes, sir.
Have you got what I am saying?
Yes, yes.
Okay. Anybody else who has not understood yet? त्यासाठी मी तो वरचा फॉर्म्युला आहे तो घेतो, जो ऑलरेडी आपण शिकलोय. हा फॉर्म्युला टाऊ ए डिवाइड बाय एस ई म्हणजे शियर स्ट्रेस, शियर इंड्युरन्स लिमिट प्लस टाऊ एम दॅट इज द मीन स्ट्रेस डिवाइड बाय एस यू टी दॅट इज शियर इंड्युरन्स स्ट्रेस इज इक्वल टू 1 ओव्हर एन. हा जो फॉर्म्युला आहे हाच फॉर्म्युला फक्त मॉडिफाय केलाय. ह्याच्यामध्ये काय केलंय आपण, सगळे फॅक्टर कन्सिडर केले. instead of considering as it is this average stress as it is we have considered, त्याच्याऐवजी फॅक्टर ऑफ सेफ्टी फक्त आणि स्ट्रेस कॉन्सन्ट्रेशन फॅक्टर, सरफेस
Sir.
फिनिश फॅक्टर आणि साइज फॅक्टर ऍड केला. हा बोला.
Tau A म्हणजे काय?
टाऊ
A.
average, that is instead of variable he has used term as average. आपण जे टाऊ व्ही कॅल्क्युलेट करतो, हा टाऊ व्ही आणि टाऊ ए तो सेमच आहे. हा कॅल्क्युलेट केलेला आणि हा टाऊ ए.
Okay, sir.
हा अजून आता काय वेगवेगळे, इफ यू आर गोइंग टू रेफर डिफरंट बुक, डिफरंट नॉमेनक्लेचर्स आर देअर. Shall we move further?
सर ते एंड्युरन्स लिमिट शेअर 0.55 कसं घेतलं टाऊ ई?
हा, शियर इंड्युरन्स लिमिट हे 0.55 का घेतलंय असं म्हणायचं.
हो सर.
ऑफ प्रिन्सिपल इंड्युरन्स लिमिट, बरोबर आहे. राईट. while we have solved problem related to knuckle joint and quarter joint, आपण काय केलं होतं, जर एखाद्या प्रॉब्लेम मध्ये आपल्याला प्रिन्सिपल किंवा यील्ड स्ट्रेस दिलेला असेल तर त्याच्यावरून आपण शियर स्ट्रेस काढत होतो का? हॅलो. हा, वैभव जगताप ना? हॅलो,
Yes,
वैभव
sir.
जगताप. हॅलो, व्हॉट आय एम सेइंग. हा हा बोला.
Sir, कळालं.
आता ते जे नॉर्मल, दॅट मीन्स नॉर्मल रिलेशनशिप आपण घेतली अप्रॉक्सिमेट आहे ते. म्हणजे आपण असं समजतो की प्रिन्सिपल स्ट्रेसपेक्षा निम्मा शिअर स्ट्रेस असतो. म्हणजे समजा एखादी वस्तू जर ताणून 100 न्यूटन मीटर स्क्वेअर किंवा 100 न्यूटन पर मिलीमीटर स्क्वेअर ह्या स्ट्रेसला जर तुटत असेल तर शिअर करताना 50 न्यूटन पर मिलीमीटर स्क्वेअर एवढा स्ट्रेस सफिशियंट आहे त्यासाठी. म्हणजे कुठल्याही प्रिन्सिपल स्ट्रेसपेक्षा टेन्साईल और कॉम्प्रेसिव्ह स्ट्रेसच्या निम्मा स्ट्रेस हा शिअरसाठी लागतो असं आपण समजतो. तसंच काय केलं की ते अप्रॉक्सिमेशनच स्टँडर्ड डिझाईन डाटा बुकमध्ये, ऑफकोर्स इट इज डिपेंड अपॉन द एक्सपेरिमेंटेशन. We are not taken it as it is. That means design data book has not provided it as it is. तसंच दिलेलं नाही ते. त्याच्यावर भरपूर एक्सपेरिमेंटेशन करून ते रिलेशनशिप फाइंड आउट केलं आणि अप्रॉक्सिमेट असं रिलेशनशिप मिळालं की शिअर इंडुरन्स लिमिट हे प्रिन्सिपल इंडुरन्स लिमिटच्या 0.55 असतं. एनी अदर क्वेश्चन? If not, then we are going to calculate this actual endurance shear stress, okay, or fatigue endurance shear stress. So this tau mean we are knowing, tau average we are knowing, tau y we are knowing, this kf, that is the stress concentration factor, as there is no any change in area, that's why factor is 1. Then surface finish factor is given, size factor is given, and tau e, that is endurance limit, 0.55 of sigma e, that is also known. So if you are going to put all these values, you will get this relationship as 560 divided by d cube plus 2880 divided by d cube. And if you are going to solve it, it is 3440 divided by d cube. Okay, have you come up to this point? Shall we move to the next slide? Hello.
Yes, sir.
Okay. Okay. Now this is about what the shear stress. Now one more stress is also acting on that shaft, and that is bending stress. So that bending stress we have to calculate. That bending stress can be calculated from bending moment, because we know that bending moment, what relationship, if you want to calculate the stress, m by I is equal to sigma by y is equal to E by R. From that we can calculate the stress. So bending stress, if you want to calculate, for that we need to have the bending moment. So bending moment is also varying from its maximum value to minimum value. So we have to calculate the mean bending moment. Now if you see the graph of this bending moment, here we can draw that graph. It is convenient to draw here now. This bending moment is going to vary from its maximum to its minimum value. So this bending moment is varying from this and further. Okay. So mean bending moment is maximum bending moment divided by plus minimum bending moment divided by 2. Just calculate the mean bending moment, and you know you have to calculate average bending moment also, that is maximum bending moment minus minimum bending moment divided by 2. Calculate these two values and tell me what is your answer. Somebody has got this answer. Yes. Okay, next. Can you give me this answer? Just do the calculation and give the answer. Aptap, what mean bending moment you have got? Aptap Sheikh.
Yes, sir.
Have you got this answer?
Wait, sir.
Okay. Nana Sahib Shinde, till you calculate this mean, we'll copy from Aptap this value. You calculate variable bending moment. Nana Sahib Shinde, are you listening me? Hello? 5 people has got this value as 110 Newton meter. Yes, we have done calculation. So this mean bending moment is 110 and variable bending moment is 330 Newton meter. Okay. Now this bending moment, if cases of only bending moment, then we can choose Soderberg or Goodman relationship for bending moment only, but it is combined stress. Now from this bending moment, as I already explained you, that bending moment can be calculated by means of m by I is equal to sigma by y. Okay. So from that relationship, first of all, we'll calculate this z. Z is nothing but I divided by y. So it is pi by 32 d cube. So that is section modulus, and that value is in terms of d, and that is 0.0982 d cube. And that will be obviously in meter cube because it is a section modulus. Okay. Now, by considering this value, just calculate sigma m, that is the mean stress, mean bending stress, and average bending stress. And tell me what value of mean bending stress you are getting and average bending stress you are getting. Jaydev has calculated it as a mean bending stress as 110. Jaydev, what will be the unit? You also mentioned the unit. And average or variable bending moment is 330 Newton meter. It is bending moment. Okay. Now we have to calculate the bending stress. Just calculate the bending stress. Pratik Deshmukh has got answer 330 Newton meter, that is average bending moment. We calculate the stress. Harshvardhan, you calculate stress now. Mean bending stress you calculate. Rupesh Dehre, you calculate the average bending stress. And tell me what are the values. Hurry up. Hello? Can we have answer? Hurry up. Calculate it. Okay. Vaibhav Jagtap has got 1120.16 d cube Newton per meter square. 1120 Yes, 1120.1. Rohit. Now this is for all that mean bending moment, mean bending stress is 1120 d divided by d cube Newton meter square, and average bending stress is 330 sorry 3360 divided by d cube Newton meter square. Now this bending stress and shear stress, now they are combinedly acting on that shaft. This shear stress which we have calculated, this shear stress and this shear stress. Okay, so we will use the previous relationship which we have learned in AME for calculating the actual shear stress. Okay, later on we'll see it. Basically, first of all, we have to calculate the actual endurance limit from the endurance limit which has mentioned in the problem. That is endurance limit which we have calculated from Moore's experiment, and that is nothing but endurance limit is equal to mean principal stress plus average principal stress into yield strength into stress concentration factor divided by endurance limit for the bending, that is for the principal stress, into surface finish factor into size factor. That is mean bending stress is 1120 divided by d cube plus this average bending stress is 3360 divided by d cube into sigma y, that is yield strength, is given as a 410 into 10 raised to 6 Newton per meter square. Now this stress concentration factor we have considered as a 1. Then this endurance stress we have calculated it as a 275, which we have calculated from the actually yield strength, that is 275 into 10 raised to 6 into surface finish factor has given as a 0.62 into size factor has given as a 0.85. Okay, now this value we have got as a 10,626 divided by d cube Newton meter square. Okay, just like as we have calculated in terms of shear, we have calculated it in terms of principal stress now. Okay, that is okay. Next we have to move and we have to calculate the actual shear stress by considering the effect of bending moment as well as the effect of shear stress. This formulae we have learned in AME as well as while we have seen the problems related to the knuckle joint and quarter joint. Do you have any question related to this? Maximum shear stress is equal. Now this, forget about factor of safety. Later on we'll consider this factor of safety. But the shear stress is equal to under root bending stress square plus 4 times shear stress square. Are you remembering this? And this value should be equal to the yield tensile shear stress divided by factor of safety. And this yield shear stress which we have calculated is 205 into 10 raised to 6 divided by 2 is equal to factor of safety, that is 1 over factor of safety under root this 10,625 divided by d cube square plus 4 into tau value, that is 3,440 divided by d cube square. And if you are going to solve it, you will get value of this D, which is equal to 12.66 into 10 raised to 3. What will be the unit of this D now? Can anybody tell me what is unit? Hello? Hello? Here it should be again. This is only under root value, which is equal to 200 IU into 10 raised to 6 into D cube is equal to this under root value. Hence D cube is equal to. Now just I was asking about the unit. Okay. You will get answer in terms of meter that we have to convert into millimeter. No doubt that if you are going to put this value as it is, because you are getting this as a result of this further calculation. This calculation will give you value of 0.0395 meter. Don't forget to write this unit. If you are going to keep as it is, no problem. But it is better to convert into millimeter. Okay. If you are going to put it as it is, no problem. You can put it. Any question related to the all this discussion, where I am going to say that the unit is completed now. Any question? Today I will provide you all PPTs of this unit right from beginning. Okay, I'll show you from where you will get the PPT. From this, that is C2.12. Not, you will not get this. So this end of problem. All the discussion which we have done. If you don't have any question, shall we move further?
Sir.